Right, we are 3, 2, 1, live. Hi everyone, thanks for joining. This is NFT smart contracts crash course as part of ArchiDAO study group, where we'll go through what is NFT, what's ERC 721, what does the specification involves, and a very high level overview about solidity, what are the things you can do in smart contract, and why having some knowledge about potential capabilities with your NFT in metadata and NFT's metadata level, you can develop very interesting utilities around it. So this will really help in your next project where you want to have decentralized app development and having unique use cases of your NFT. This session will open up your mind about huge potential which you can do with NFT. And I know like people who are watching this ranges from like beginner to like intermediate and expert level. So I'll be honest, when I was starting learning blockchain, first few sessions, like it was way above my head. It took me a couple of rewatch and revisions to understand this. So just to say, like it's a bit complicated, but with time, with some hands-on exercise, you will be able to understand this. But I wanted to this session to be as friendly as possible. So if any point, if I'm going too fast or if I said something which in my mind I thought I explained it pretty fast, but you want some more clarification, feel free to interrupt because your questions will be helpful to a lot more viewers who are watching because they might have similar thoughts. So feel free to stop me at any point. Right, so let's cut the chase. You can see my screen. Um, First, let's see what is NFT. So NFT is you might know stands for non-fungible tokens. It's ERC 721. And what is ERC? So ERC is Ethereum request for comments. So for example, when Ethereum blockchain developed, so they have on GitHub. Is my zoom bar blocking the view? Okay, I can move it. So once you have the blockchain, people have ideas and they want to develop standard for it. So you can do proposals for your standard on Ethereum on GitHub, where you can write, this is my idea. This is how, if we develop a standard around it, we can develop a lot of potential use cases and stuff like that. So ideally, if let's say I want to develop a 3D marketplace and a 3D standard, I will be submit a request, an issue on Ethereum that, okay, what if there is new 3D NFT standard where instead of image, we embed 3D model and all the metaverse and all the protocols should abide by it. And if it becomes accepted in the blockchain, then you can develop a whole ecosystem around it. So this is the way you people ERC20 was standard for tokens, and like 20 stands like the 20th proposal in the ecosystem. So before ERC20 and SAN21, there are a lot more standard are in the ecosystem, but like these two are the most popular ones. So what does ERC 721 do? So it's an interface for non-fungible tokens indeed, and we we might think how it's affecting AEC and what are the potential like implication. And it's first important use case they have mentioned is people can use this as a physical property deed, unique artwork. And in last year we saw a lot of explosion in NFT as artwork, but like there are people still some projects which are working around like getting NFT as did in housework. but also you might need to know a lot of legal implications if it's uh what if it's like what's the liability of your NFT holders and stuff like that. But these are like some basic use case when they proposed, I think this 2018, um, they had in mind. So, and you may think like, why do you need a standard, or like, why can't you create your own? But it's the way how like global communication works. Like, let's say you buy a domain name, it's a string, and we needed to have a standard where, like, let's say everyone who has to upload a website, the browser understands the standard of HTML language, JavaScript language, so everyone can globally communicate and have on the same page. Even like as we see in our house, for the plugs you put, there's a standard that okay, every electronic appliances should match to that standard. So this NFT standard has various other things apart from just owning a string or images. Like whenever there is a transfer from my NFT to your NFT, there is an event transfer call which is being, and every NFT project should have this event. So how this is helped? So event are different than transactions because each transaction costs gas money, and it's difficult to like get that storage on chain. So with event, you can easily write hooks that, let's say, when I could write a hook when Shri transfers her NFT to someone else, uh, give Shri 10 points. So like, because when events are being emitted on blockchain, all of this data, I even like 10 years later, I could find what time Shri did this, and if I want to develop anything on top of it, I could do such kind of things. So this is like various things mentioned: interface, token receiver, they have metadata schema. This is one of the most important things. So minimum, at minimum, like uh, your NFT should have like a title, should have description, should have image, URI pointing to meme type image. And additionally, you can will go through OpenSea. You might see metadata about like, can the NFT have some characteristics like strength, agility, rarity. And once you mention that in your metadata, those are additional things. People can develop interesting gaming or metaphors use cases where, what if you bring life to your character where your attributes mentioned of strength 8 on 10 here in the metaverse. You can develop a battle where one NFT character is battling with another NFT character, and you can do trading, play to earn games, stuff like that. So a lot of interesting use cases, because this data is public, is on chain, anywhere from any web 2, web 3 interfaces can use this data to reward the users. So we got the scope now. And then, yeah, so we covered ERC and ERC 720, which has its own protocol. And like, this is a comparison of ERC 20 here and ERC 720 when here. So ERC 720, like basically we are minting, where like give 20 tokens from my account to that account. So you have this to address, you have from address, which is like my like sender, and you basically have amount. So ERC 20. One additional thing ERC 721 has is not only like each token is unique and each token has a wallet address or user address associated with it. You can also have additional data that every time I'm querying this function like token 520, give me token URI, which is also stored on chain. I don't know how much you can see this, but there's this token URI function which stores a string associated with that token ID. And that is one interesting use case where like every time I query this on chain, like token ID X gives me this string. So this, like when I was learning about NFT, like from reading, it was one perception, but from coding and doing it hands-on, it took me like a kind of a shock, but like not that big. So NFT ownership is basically you are owning the string, nothing else. Let that absorb a bit. Like when you like when you're transferring the strings or like transferring ownership, you're just transferring like who owns the string. That's it. But the one thing is many people don't check uh, the storage of the string. So right now it's on IPFS, which is decentralized storage. You can even have like a Google Drive link or Amazon storage link or your own website link here. Now, what's problem with that? Let's say you develop your NFT project, other protocols, other interfaces are using the metadata embedded inside the string. What if suddenly Amazon storage goes down, your website goes down? All of your NFT holders can't or like other protocols can't use the metadata stored here. So that's why it's crucial that you check where is the being stream stored, and yeah, like basically you shouldn't get scammed because this server went down and no one can now use your NFT. So one gotcha, one thing to keep in mind. And we talked briefly about metadata that we you need to have name, so image URL. So currently this is HTTPS, centralized storage, external URL description, stuff like that. So how does this map into OpenSea? So whatever name you have, it shows here, description, uh, and you can like these are the attributes. So when I was talking about various traits and things, you can develop like value 3 slider date. And let's say I want to develop now a game where the age of my character represents the age or date here. You can do things like that. I hear some background noise, so uh, if you guys can please, thank you. So yeah, so we know now this metadata, how it's being reflected in metaverse. And this is one of the example of Bored Apes where uh, you can now have rarity. So let's say you have 50 characters of your NFT collection. One character is only 20 made, another, but it has a very high strength. So, and another character has 100 mint, which has semi mid strength. So now you, with rarity, you can also set minimum base price that whatever NFT has 20 rarity, have at least like minimum mint price equal to 1,000, with 200 minimum mint price equal to 100. Like you can like think about how to use these traits and like develop your own NFT project. So are we good till now? Any questions? Cool. Looks like I'm doing a good job. So we know now what is NFT, what is metadata, how does OpenSea does listing, and uh, this is the smart contract on Etherscan. And wait, I'll step back. I should first let you know what is Etherscan. So let's do a walkthrough of one of the projects. So this is Cool Cats, and So when Cool Cats minted that NFT project, they had this name, they had this description, in their metadata, they had this traits. And if I want to know what was their smart contract, everything is when people say distributed public ledger, what is that ledger? So we'll see. So when I click on this contract, it takes me to this ether scan. And like your wallet address, your contract even has an address. This is your contract address. I could see all the people who are currently minting it, transferring that NFT in this contract. So when you sell your NFT and you find a buyer, like this is the event which is being happening on that particular NFT, you could see the new owner, where it was, where from, to, and stuff like that. And if I want to check how did Cool Cats write their smart contract, because it's verified, uh, you can see all the functions. So literally, if you want to make Cool Cats version 2, you can copy paste this code, mint your NFT smart contract, and you can do it. So this now opens a new way of trust, where the business logic of your application is public. And because it's public and I know all the holders, you can develop interesting layered logic on top of it. What I mean by that, so I can create my NFT smart contract and I can have a function. If the current holder, current wallet address is a Cool Cats NFT holder, give them 10% discount. Or if the current wallet address owner has, let's say, hyper tokens, give them additional utility. So things like that. Now, because it's public data, you can develop very interesting layered logic on top of it. So there are two things anyone can do with your public data on chain, like with the NFT smart. So there are read functions and there are write functions. So read function is basically getting to know all the data which is uh, on chain. Like, so for example, when we were looking at this NFT, how do I trust OpenSea? Like, what if OpenSea in their website just like modifies anything and list anything? You can check it whether this is the actual owner or not, or everything related to this. Like, so currently like 6060 is the token ID, and like this is owned by Good Karma. We can check everything related to this. So token URI, bit flashback, token URI. If I give token ID, it gives me string. So I should be expecting string. And currently I'm calling this string from this interface, but you can have your own website where you can call that function. And we will cover that at the end, where how you can create your own decentralized application. Oops. Okay. So the reason this happened because I copy pasted and there's a space here. So look, we got this token URI, and this is free, no gas fee, no prompt, right? So it gives me this metadata, right? Description. This is the same thing which reflected on OpenSea. This is the IPFS image, Google Drive image. These are the traits. And this is the main image, and 6060 here. Cool. So this is read function where anyone can call, anyone can do. And there is this write function. Let's say I am the NFT holder of this and I want to transfer this NFT to from my account to another. So you can do whatever the OpenSea is doing with a very good UI UX right from this public ledger, where I can see my address XYZ. I want to share this to anyone in this call. I'll get your address and I'll have my token ID. Let's say 60. So what it does is it checks whether this from address is the current holder or not. Yes, make the new owner of this NFT this. So let's do. So I don't want to go to small details, but like this is some action items for you if some of these things you're hearing it for the first time. So MetaMask is your wallet. So right now, oh, it's asking me to connect to mainnet because I'm on testnet. So so Ethereum mainnet. So this is my developer account where I just use it. It's an extra account. It's asking me to prompt, connecting it, and it's now connected. And now I can make this calls like same my L input. So your wallet address, this is also one of the scare I had like when I was just like, should I share this wallet address? Is it safe? So your imagine this URL as your email. It's safe. You can share your email. But your private key and password associated with it, don't share. People can literally take all the money. You can't even do anything about it. So I'll say this and I'll take one of the people's address and then I can write a function and then it will again do, let's say, a prompt call. This is gonna be fail and stuff like this. So this is how OpenSea is also doing, but it's doing some auctioning and matchmaking, which is additional logic they have. So we now covered what is read and write function of your smart contract. So once you mint it, and you can cover all this. We covered this three part, and then because like there is a mint function here, you can create like additional cool things or stuff of it. So this is one of the experiment I did where I had like this on chain instead of image like a SVG NFT, but while minting, I'm asking user what name you want in your NFT and what background color you want. And when they're making these calls, uh, they mint it, and ultimately on their OpenSea, you get this dynamic NFT. So now this becomes quite interesting. Where let's say, as 3D artists or like modelers, you want to create mutual ownership of your NFT holders and your uh, parametric building design, which they can use in metaverse. You can have your front end or decentralized app where people can select number of rooms, sliders, and various dynamic input, and they customize your house for which they want to use in other metaverse. And then they click on mint function, and then that customized mutual ownership of house is owned by them. So your IP and your utility is the configurator of 3D model configurator you're providing, or even it could be parametric script, whatever you want to do, and then have this kind of dynamic NFT logic. This becomes very interesting. And if you want to develop like composability, let's say kind of like what you can do with like hypers, layered logic, let's say, uh, Richard develops this parametric stair and Shri develops this building skeleton NFT. If I have ownership of both, can I integrate them and do my own custom like building design on top of it and like have a derivative NFT, or I can I like you because I own NFT. you can also have like some IP related to it, because let's say many times people do workshops and they share workshop material which they have worked for a long time, and then students get it and then students start sharing it, and ultimately there's a point where no one even knows who's the workshop, like who's the original creator of this. But if you have like NFT usage of that workshop material, you could keep track, and let's say your students now become the new workshop instructors. You can find like make some logic around it that you might get some royalty if students are doing more workshop on top of material of your 3D material, stuff like that. So this is like very uh, open world where like we could create a lot of innovative NFT utility projects here. Any question till now? This was the fun and easy part, because now we will do some hands-on stuff. So uh, it's good if we can if you want to clarify anything related to NFT right now. Nope. Cool. So we got the OpenSea NFT. Let's do why do we need Solidity? Like if I can do everything on OpenSea, yep, you might be thinking, why? What's the point? So I'll tell you why. So I'm creating an NFT using OpenSea. I can create any image. Let's see, I have this workshop certificate. I can create this link, external link. This is my collection. You can add properties. This is like we are now writing the metadata for this. Hierarchy, uh, parametric skills. Uh, wait, this is type parameter. Okay, what should I add? As architect, I can have pro level, then I can have mid level, stuff like that. Then I can have numeric skills where design, you can have 5 out of 5, additional things like that. Is it unlockable? And this is like strength, or like I can even have like other attributes. This is on Ethereum, like, and what ultimately when what they save no gas cost to you. So everything you do has some gas cost. Either the NFT contract owner pays the guest, or you offload the cost to the your new NFT buyer. And one could argue like, why don't you pay the cost and have a seamless experience for your new holders? And I could say that's your customer acquisition cost, where you're paying some gas fees for them to buy this. So pros and cons of each approach if you want to offload them. So you can I don't know if we covered this. Okay, so Ethereum is layer 1 blockchain, Polygon is layer 2, and for scalability reasons, there are like layer 2, which has faster transaction, cheaper gas price, and there are like various layer 2s with optimistic rollups, stuff like that. So for example, don't quote me on this number. On depending on the traffic on Ethereum, one minting NFT or one transfer NFT can go from $20 to $100. In Polygon, it might be on pennies or cents. So this is the price difference we are talking here. So one could say, then if Polygon is cheap, why is not everyone using Polygon? So there are pros and cons for that. Like if Most of the OGs Ethereum collector are on Ethereum. It's easy for them to buy tokens, sell NFT because they have all of their assets on Ethereum. Polygon is new, so you might not have that reach to those many collectors. So yeah, that is one con. And yeah, so freeze your metadata is like, as I said, like if one con of having centralized storage is what if servers goes down? What if it's not freeze? I create an NFT and I tell it's rare, it's 50, and suddenly 2 months later I change my mind and I change the rarity to 100. So like people who bought that NFT thinking about the rarity, I'm not doing justice to them. So that's why like it's also important to check whether the NFT metadata is freezed or not. Oh, there is some chat I forgot to see. Okay. All right. So yeah, create almost done. Come on. Am I doing this live? Okay. So I created this NFT. It's not in the sell market yet. Then I can list the price, like minimum 0.01 ETH. What should I wait? Service. So this is how OpenSea makes money. For all the transaction and listing, it takes this much money from that transaction. I'm signing it. Yeah, simple, right? Now, like, okay, everything I was doing on test network. So, oh, wait, okay. I think I was on Polygon. Okay, yeah, so this is mainnet. We can also do it on testnet. Uh, what was I saying? We can now buy this free NFT actually. The things which this open template does, it's good for like basic NFT minting and utility. But let's say you have the NFT collection, you have a community of 200 people, and you have some members who have been like working with you for a long time, helping you build this project, and you want to give some discount or do some free NFT. There's no function like whitelist NFT here, or there is no function of like doing computation or like dynamic NFT use case I was talking. So if you want to develop very interesting use case and like some complex interdependency of NFT, you can't do that with OpenSea. That's where like NFT smart contract is good to have that skill set, because now you can develop very uh, innovative utility and use case for your NFT. So OpenSea is doing this as their huge collection of ERC 725, and this is their OpenSea smart contract, ABI, and code. And you might be thinking, wait, we were talking about this Solidity language. What the heck is going on with ABI, contact creation, argument? What is all this? So like we have programming language because human can understand this. Like computer don't need this, and like all this spaces and all this definition is not efficient. So every like you have a compiler which converts human readable to computer readable, and like binary, as we all know, is most efficient way like to communicate. So all the code here is being compiled into binary, and that's where like we'll go to remix that before you do smart contract minting, there's a compiler which compiles this code, and there's this contract ABI where all the functions we saw in read and write contract, this is being created. So you can provide interface with your contract code on blockchain. So this is being converted into these two forms. And when you develop your own smart contract, all I need to do is give me the contract address of this, and I want to call, if I'm doing mint function, I want to call a mint function here. If I'm doing transfer function, I want to call a transfer function here. And what are the inputs I need? What are the outputs I'll get? Everything is being listed. So it's how. So yeah, let's do a bit of, yeah, solidity. So when I was saying contract, this is the compiler. We saw this bytecode and this ABI, which are the function calls. We just discussed this. So I think it would be easy if we do. You can do hands-on with me right now, or you can just watch it. It will be also live on YouTube uh, later to follow up along. So this is Solidity by example, and very basic hello world is like you call the version for this Solidity, you identify the license, and contract is like your class, if you know like object oriented programming, and you define like here string type public. Now everyone can just access this. So let's try it on Remix. So we can create my own contract. Let's say tutorial session. I need to keep track of time. Okay, and yeah, let's do basic copy paste. So what does your intuition say? When I launch this contract, there should be some public variable like greet, right? So human readable. Next step is compiling this. So I'm compiling this. Third step is now I want to do interface with it. So I haven't, like this is all in my memory. I need to deploy it in blockchain. So there are three ways. One is creating, if you are experimenting, you want like quick feedback, whether this is working, where is it failing, similar to like Web2 where you are developing your website, you run it locally first. So JavaScript Berlin, like here, they're creating their own local like blockchain. Pros and cons. Pro, very easy and fast to test. Doesn't take much time because it's your own local block, and there are like, let's say 100 blocks, so things are happening very fast. If you do it on like main Ethereum, like there's so many blocks, so it takes so much time. That's why like sometimes we wait a lot for gas fees. But if we are just developing this, we don't need that. Then there is this injected Web3 where I can use the same code and launch it on my main Ethereum network. And I have two options: either launch it on uh, whatever address I have, it will launch there. So I can launch it on mainnet, or I can even launch it on testnet. And if you don't see this, you might need to click on show and hide. So this is on testnet where I can like, if you want to get Ethereum, so testnet is, you can get Ethereum for free on testnet. Link be faucet. So whatever chain you want, just type faucet around it. So you go here, you type your address, they'll give you ETH. And this doesn't hold any value. The value is like you want to feel how much time the transaction is taking. So you deploy it on testnet and fill it. Because you might see here once we deploy in our own local chain, it's like not even a second. And this is not giving you the actual UI UX experience of your contract, because when you launch on main main blockchain, you wait, let's say 5 seconds just for deployment. So that's when, like, once you have your logic ready and you want to feel like what are the time taken for each functions call and stuff like that, you do at the testnet stage. So we deployed this locally, and if I want to interface this, like, look, we have this string which is public, and it's returning this. So anyone, like if it's on testnet or mainnet, who has this contract address can now access this variable by making that call. And you will be like, wait, okay, that's a good start. Now what if, let's say you have your token, or you want to make like a vending machine where every time you put a request, it's increasing by $1 or something, some use case where uh, this is another basic smart contract where I'm calling this get function, where it's public and you can access, and it returns unsigned integer of what is the current value of count. And when I'm making, so this is view function. So as we saw earlier, read contract, view function, no gas fees. Here we are modifying the variable of a gas, like variable. So this should uh, account in gas fees. So here we are incrementing it, and here we are decrementing it. So let's just test this. So I have enabled this auto compile, so I don't need to click on this every time. But if I now click on this, so current count value 0 because it's default, increment count value 1, decrement count. So now no one can like change this. And like this is the kind of trust we are developing. Let's say uh, I am developing, I launch my own token, and I'm saying increase the token price by 10 cents every time someone new mint. So my first token is $1, $1.10, $1.20. And then this is immutable. And now this has built-in incentives, like for all the new token holders who are buying on early, you're rewarding them by buying it on cheap. So either they can hold their tokens for a while and sell it later, or they can continue supporting your project. And you can write that logic pretty easily that, okay, every time there is a new mint function, price equal to price plus 0.01. Like there's no currency like this. We need to write in way, which is the lowest decimal of ether. But this is the logic I'm trying to explain, what kind of logic you can now embed in your own smart contract. So yeah, Solidity by example is a really good platform where you can learn. Let's do this. So we know how to launch our own smart contract. Let's know what are the type of variables. So we can do Boolean, integer, address. And now because each transaction gas fees is dependent on how much storage and you are doing on chain. So it's really important that if you know the variables are between 0 to 100 versus variables between value between 0 to 50,000, you select like unsigned 256 or 128 or unsigned 8 to save memory of your smart contract, because you have like high integer, you will ultimately cause very high gas fees to your end user, because every time they're minting, uh, they're gonna pay a little bit more because you haven't designed your smart contract efficiently. So that's why like not only developing the logic but developing it secure and efficient is important as a smart contract developer. So then there are mappings, so where you can say address, unit ID, public mapping, and you define that every time I call this address, output this. So we already saw this example where we have in token URI in NFT, it's a mapping where every time I input any token, give me like a string associated with it. So this is how like token URI is a mapping of integer to string, and becomes interesting because now you can say each token ID, you can have another URI that, what would be a good example? Uh, Token URI, whether you can have like if this address is ArchiDAO contributor Boolean, so yes or no. So anyone outside the contract can also access this, that kind of. Then you can do struct with like if you have your own like multiple variables defined in that struct, where what if I want to develop let's say and a smart contract where I have this additional utility. Let's say if I'm getting person's age, if person is less than 20, make give them type NFTA. If person is less than like more than 55, type NFT. Like and this if it's public and stored on chain, I can use this characteristic and now in my metaverse where, oh, this NFT holder, this is the image, but also there is additional metadata. Can I create a virtual avatar from this? Things get become very interesting because everything is now public and on chain. It's accessible. And now there is this require statement where let's say you have a logic where while minting your NFT, the user should pay minimum of $20 when they're calling the mint function. So this require statement can do a check that if message.value, which is like your gas fee, is less than 20, cancel this transaction or don't mint, or yeah, stuff like that. Then you have access modifiers, whether you want to keep it public, private, internal, external. So you can do this. So I think we don't need to know everything because like we are not learning the language, but these are 3, 4 things. If you know, you can get very like creative with smart contracts. So I'm giving only the things which would be useful for your immediate use case. Yeah, and yeah, this is again another good cheat sheet of NFT smart contract. So hope we did some very high level solidity basics. Any questions? Which string are you referring, Richard? So like every, I don't know, like which blue are you referring, but
So I
it's a
mean, like
mapping.
when you were saying, yeah, when you were saying, no, like each thing has, like you can give that a character, like different character, right? It's blue in color, like, and it is Arkidao metaverse thing that you were showing. So basically, you're giving the characters to your NFT. So is it like doing it, or it's just like writing about it?
Yeah, so I'm writing uh, like a public data structure. Like let's say, I think the class was a good example. So let's say I'm creating my own metaverse on let's say 3JS or in Unity. Now I have this generic avatar, 3D virtual avatar of a person. And I want to say, let me customize all the avatars by like whoever is logging with their wallet and whoever is ArchiDAO like smart contract holder. And what I'm doing on my Unity or 3JS is get this wallet, get the person variable, and render like get like if there's a color here, give me person dot color like this characters dot t-shirt color equal to this uh, wallet address person dot color. So now every time you log in, everyone will have their own custom avatar because this is out in public and out in blockchain. So we are not
So,
rendering it, we are customizing
mm,
it based on data on blockchain.
so like it will be actually a hue, like RGB color, right? Like this is the color, or we just saying in the string that it is so and so color for this person's age.
Yeah, like we are just giving out anything. Like you can define blue as BLUE, I can define in capital or what. Like it's in my application, in my own metaverse, where I'm saying there's this string out here, and based on this string, like do customization, where I can say, okay, whatever blue string in capital or small caps they have, like for all the strings definition, render a blue color in my Unity or 3JS avatar.
Okay, so next question I have is like if like each time I'm customizing for someone, is it going to charge me more gas fee than in comparison to like when you have the same color for everybody?
Yeah, so this is uh, things we are reading from blockchain. So no gas fee. So when let's say ArchiDAO is doing a custom NFT variable, like similar to I was talking about, like dynamic NFT, and I say, let me get a person's name while they're minting, and also color of t-shirt they want while minting. So when this they mint, it's on OpenSea. Because now these variables are on blockchain, I can even say if there is a background color like this in my whatever application I have, give me this variable name and render my virtual characters in my application accordingly. So I'm just calling it, like it's already being out there. When you minted it, when you paid gas fees, when you created that variable, you already paid it. Now let's say there are 10 metaverses, all the some metaverse wants to use your name, they can just access your name variable. Some metaverse wants to use your color, and maybe the building or room color changes based on this color, you can also do that.
Got it.
Yeah, it's similar. Imagine like what if your Instagram data is in a centralized or like decentralized storage, and now every metaverse can use this data and give you a personal customized experience. So maybe that's not the best example, but you can see you can do very interesting things. Yes, so we have a question about creating smart contract and making it efficient. So which functions and methods should be used heavily? I think it depends on uh, the purpose of your smart contract and utility. Like if you don't foresee that like for example having this person struct, where is it, uh, person struct, no one is gonna use this, and like there's nothing relation in your NFT, like was you can like avoid some storage or utility of this. So whatever you're writing here, like you have it like a bit of broader thinking. If there's a vision and if you could see foresee this NFT, utility in much more novel ways at the time of minting, but also like like for example, I can't have like another variable where people can write paragraphs and store as string on blockchain. Like people would be paying a lot of gas fees. So then you need to think about smarter ways. Like, can I create one function where all the paragraph are stored, but it's stored on, let's say, IPFS, where if I click on this, it creates like a IPFS link of that storage, and I'm just getting this CID, like content identifier and what's data. Uh, so instead of storing the string on my smart contract of blockchain, like the whole paragraph, I'd store this thing. And if people click on this, it will show up this NFT. So then you're thinking about optimizing storage, optimizing exposure, like some uh, yeah, that's whole another contract security. People pay heavily to do your smart contract audit, because what if you have some loophole in your NFT where if you're giving like let's say additional discount to all the NFT holders, and it's just like an address, what if I get some other people's address and call the same function? How do you verify it and stuff like that? So I think ensure your metadata and ensure the public variables, or like NFT specific variables you want you want other people, other applications to develop on top of it, are like efficiently stored. That would be like a good starting point. Cool, guys. It's almost an hour. Okay, time to pace up. Okay, so I know you have been thinking, okay, we solidity smart contract, we signed up for this session to mint our own ERC 721. Why is this long session? Cut to the chase. So let's cut to the chase. Whew. So open Zeppelin, like wizard. This is gonna be your life savior. So if I if I want to create like some sample contract, I don't need to define everything from scratch. I foresee this like import statement, like if there are like some functions you use frequently, you can use like import that as a library, like npm install or python install or something. So yes, like open zeppelin has done the heavy work and defined all the functions complying with the standard of ERC 20 and giving out in the form of this. So you don't need to write your own token functions from scratch, and you focus on the customization aspect. So literally, if I want to, and this is very modular. So let's say I want to have my tokens. This is ERC 720 we're looking. You can write the name, symbol, and you can say it's mintable. So if I get this out, people can go on Etherscan or my own website, and they can start minting the amount. And then you can save how, like, some depending on the tokenomics. What if there's a lot of supply, the price of your token is going down, and you want to reduce the supply so the price of the token goes up? You can have this function called burnable. Let's say you have your token, people are misusing it, someone scammed it. You would like to have the power that pause this smart contract or pause this tokens, no more minting, no more. So you can add that too. What if now you thought, okay, my token blew up and now I want to develop a DAO around it. So now you can develop a voting standard where if people who have at least 100 tokens, I'll give them voting right. So you can add start adding those functions. Then there's like snapshot. So man, should I go into this? Okay, so what if, let's say there's a voting for your DAO coming up, and just because I wanna, if the voting is weighted on number of tokens you own, what if just before start of the voting I buy thousands of tokens and do the vote, and if vote is not going on my favor, I sell it, or I immediately sell it after my vote. Like, so you need to take a snap where, like, before the voting is passed, I want to check how much time the token has been holded for a holder, and at the time of approval is the amount of tokens being holded to that point as well. So you can take like block snapshots. We will do store snapshot and retire later. Punching voting. Yeah. Okay. So fungible tokens, and now we are going for non-fungible. So let's do very minimalistic so you can start implementing. So you can have your own, let's say, ArchiDAO symbol. I can have my URI, and either I can have my own website, or let's say, oh man, Shri is gonna. So I'm creating a Shri 100 NFT where there's a URI link. I'll call this mintable, and you can have logic like this, that I, as the owner of this contract, can only mint where, let's say, we did a workshop and I want to mint this workshop certificate to all the participants. So I can call this functions to address. I can give like, okay, certificate number 1, 2, 3 token ID. But then you think, oh, there are like 1,000 participants. I don't want to make an array of all the list. What if I just give it out there, the certificate names, and let the people mint it? So you can remove only owner requirement, okay, here, and now anyone public can now mint it. And the logic, the problem is right now, who's keeping track of token ID? What if I mint token ID 1 and now I have the URI associated with, or someone else does token ID 1 as well? And there are various checks inside, but what if you want to automate that, where every time publicly mint, the token ID value is going up? So if I mint 5 NFTs, token ID 5 is gone, and then next time I'm calling the main function, automatically there's a token ID 6 associated with it. So you can do that. Same function of burning your NFT, pausing it. Things become interesting. I think URI storage is something you would like. And for example, right now, this is base URI. This will be also a public function where every time I call this is gonna give me this base URI link, and yeah, it's the storage associated with all the NFT holders. And because it's auto increment and this slash, it will start adding like 1, 2, 3. So what if in this collection there are few strings, like few, let's say token ID 1 to 20 are rare NFT, and I have a different URI, and token ID 21 to 100 are semi rare, and I have a different URI link. So same collection, different types of NFT image or different types of metadata. You would like to change this base URI URL. So should we go into this? Yeah, the thing you would like to know is you can customize this URI for each mint and have different metadata for each mint. Cool. And let's say you are a DAO, or like you are an NFT holder, but you want to delegate that. I don't want to mint every time, but I want to have my assistant or like someone else does the minting for me and like make that calls. So you can even have like various rules that, okay, let me define an operator role or admin role where uh, if I am the NFT holder, I give the minting power to, let's say, Shri, that okay, Shri, now you can mint as well. You have that power. So I can add Shri's wallet address here, and now you can distribute the powers. So things can become very interesting and complex here. So let's simplify a bit. So this is all. Like you open in Remix, this is the smart contract which got here, got compiled, and this is our contract name. This is all the import contracts it's calling. And if I click deploy here, it deploys locally. If I click here and if I select, let's say, test network, and I click deploy here, it's asking me, I don't know if you see the screen, transaction, I have this ETH, confirm it, it's creating, wait, you can see view on Etherscan, it's still pending. The verification is going on of proof of work. And in your wallet, you can also see, whoa, okay, it's April 10, right? So this contract is being deployed here. And you can see it's not verified. So should I go? Okay. So now, in order to verify this is a trick. I think like not many people tell, but it's important to give this utility to all of your NFT holders. So you need to flatten it, and did I save this contract flat. Oops. This is my flat. And if you want to order verify your contract on here, you click verify publish. You have single file. What is the 0.80? Wait, it's very early version here. And let's see, like MIT license. I paste I just copy pasted the flatten because now it's getting all the dependency of other contract. And I'm not ever going. Wait, is this a chimney? I will do that. Okay, done. Done. So we are now unable to generate bytecode. So if I difference, okay, we messed up with the compiler version. Zero 0.8. Let's try again. This works. I have done many ways. Oh, it was 0.8.1. Hmm. I saw that error somewhere here. Okay, let's give it another try. So we are doing this step to make that read contract, open smart contract, and write contract utility to all of our NFT holders. On. I need to verify everything. 1185. 1185.
Control app doesn't work here.
Yeah, generally it doesn't happen like this. Okay. This is my last attempt. It's not a big deal, but
I hope you select the boards.
dude, it's tricky. AI is messing with me. Wait, what is this? That's- Time to embarrass. Oh, I didn't embarrass me publicly. It's okay. You're almost there. I appreciate your patience. Ultimately, this bad luck today. We tried looking for a match from list of unable to find an exact match. But good we are looking. Oh, okay. I know the problem. Because we deployed the only the base contract, we need to deploy the flattened contract. Okay. So same procedure where we compile this flat contract and we need to deploy this ADAO flat contract. I'll just explain what happened. Any questions you can ask meanwhile?
So what is flatten contract and the other one you were saying?
Yeah, so this is our original contract where we are importing this uh, files. And if you see here, these files are being downloaded here from this GitHub repo, and we are using that functions here. But in flattening, we this separate files are being flattened into one file. So all this import, these files are being combined into one single file. So we should verify this flattened file. So yeah, you can do multiple files as well. But this would be easier. Oh, no verification. Nice. Oh, too much, too early. Come on. We're done, right? Fingers crossed. Yeah, you deploy your contract first on chain, and that's where actually uh, all the protocols now can access it. Guys, we are having bad luck today. Oh,
We'll not judge you. You can move forward,
Yeah, we can
maybe.
move on. Yeah. I'll make a separate video, but it's not a big deal. Like, so we can have unverified contract, and oh yeah, actually, it's not bad. So we have this. We were verifying it because on Etherscan, uh, we wanted people to call the functions, right? So this is my contract, and if I want to do mint function, transfer function, there's no availability here, but I can do the same from Remix. So yeah, they're unstoppable. So it gives, I'm the owner address. This is my wallet address. This is reflected here. So everything is on chain. It's not uh, accessible on Etherscan. Even OpenSea can basically call these functions. So I haven't minted anything, but if, if someone wants to give their smart contract, can someone give me their wallet address? It's gonna be on your test net. Perfect. Let's do this. Thank you. Oh, why it's like that? Copy. I need a URI. So much tabs. Okay. So right now I'm minting to this address which was shared on the chat. Uh, this ID. Let's do transact. Paying this much gas fees. So yeah, depending how much you optimize, you can reduce this cost. And let's say you're making 1,000 NFT, like adds up to a lot of your people. And when they're doing secondary sales too. So it's pending. If we were doing this on local chain, it would have been instantaneous. But now we are mimicking this same transaction on test blockchain. So I'm not also like paying my own money. It's like test free money. Oh yeah, successful. So now you can see the new owner of token ID 1. Actually, this is the first owner. We are minting it. So is this address. And what can we do about it? So now if I type token ID 1, look at what we got this URL. So and I type token ID 1 here, I can check this new owner. It's not me, it's the address we got. So this is how you can deploy your quant. But we didn't talk about what's going on here. So this safe main function is being referred from ERC 721 here. And what can I know more about it? So if you click here, once you import this, it will download these files. And these are the original ERC 721 file where you can go deeper into what's going on in this. So when you see balance of function, it gets the owner wallet address and returns me the string like integer output of this. I think it's a mapped array. Yeah, balances. This is another where every address have their balance, and this is not token balance, this is NFT balance. So if I buy 5 NFT and I type my wallet ID, it gives me 5 NFTs holder. And you might think, how is this balance updated? So that's uh, where is the mint function? Safe mint. So this is what we did where to address, token address, I can add also additional data. And this is calling the mint function, safe mint to mint. And this is an event where the standard requires before token transfer event after token transfer event. So you might think, let's say you are minting this, it's happening on blockchain. And if I have my NFT listed on OpenSea, and let's say I just trade on another website or Etherscan my NFT, how does OpenSea knows about it? So these are these events being transmitted where I can see, oh, okay, the new owner of this token ID is this address, and let me update my OpenSea web page or things like that. And let I don't think this is an interesting use case, but let's just tell it. So let's say I have another contract where I'm an artist and I decided I want to do fundraising using NFT, and people who buy my tokens for next 6 months, whatever revenue I earn, I want to give back to all the NFT holders. And I can write like a stream, super fluid stream where money goes in, goes out to all NFT holders. But then you might think, what if the NFT holder changes hand and they sell to another? So I need to update my income stream to the new holder. So you can write another logic where whenever for this NFT contract is, if there is an event called after token transfer, you got to update your income stream. That's like a alert or hook that, okay, update your income stream to this new token address. That's how from external blockchain you're keeping track of events happening inside blockchain. Hmm, dude, I'm just worried I'm getting too much and it might be information overload. Feel free to stop me. So yeah, you can go as deeper as you can here. And in this, you can even, let's say you want to do only 100 NFT. I can have a require function where, like, say, token ID, if wait, there's no self increment, so we need to import that self increment. Token ID should be less than 100, else, so if there are 100 tokens being minted and someone is trying to uh, uh, mint additional token, the safe mint, because it's a requirement and this doesn't match that statement, it will fall. So it will say transaction failed, and I can say the uh, uh, reason that all tokens are already minted. So now you are adding more utility here. Like, let's say I want to limit my token holding, and let's say ArchiDAO is organizing a conference, and we want to give all the metaverse workshop certificate owners 10% discount. And I can have like a public function where while minting, uh, have, what would be the best way? Have like ticket, conference ticket value as input. And let's say we decided $100 minimum ticket. I can write a logic here that if uh, the the owner or the minter message dot sender, it's like wallet address is like, don't don't literally follow me, I'm trying to like convey the logic. If is holder of, let's say this is the smart contract address of, it would be like 0x form of our workshop NFT. And like, let me give you what I'm referring to. So this is the workshop NFT smart contract we give to all the futurely participants. If you want to check, wait, oh no, why is this in this collection? Okay, if you want to get details, it's verified. So okay, this gives, and this is how I flattened it. It's in one contract, and I want to get this address and say here that people who are holders of this, uh let's say uh, ticket ticket value, maybe give like some discount. I'm trying to say like you can add logic here and give additional utility to all the other NFT holders. Or if I could even say there is a what do you say, I can have like a array of whitelisted uh, address owners or something. And if I have like bunch of your wallet addresses, I can even write the logic of, okay, give them like percentage discount or give them additional utility to metaverse or something. Things can become pretty interesting and everything is on chain. Like that's the best part. Like if like, I could create my own like website and have this, and I can create, okay, let's ArchiDAO website, ArchiDAO Web2 tokens. But since this is on chain, let's say ArchiDAO has sister DAO, or we have a partners with another metaverse. Let's say Decentraland Metaverse is our partner, and Decentraland is now saying whoever is the ArchiDAO token holders or NFT holders, we want to give them a variable. Since all these addresses are on chain, like they can do it. If like you can start having very layered business logic. That's, I'm not sure I'm like communicating it the best way, but things become very very interesting once you start bridging this and adding more interactivity. Cool. I think we should be at the old. Are you guys interested to know about how to deploy NFT Dapp, or should we do it for a second session? Dang, I'm getting no response here.
Could you give a short description of what Dapp is?
Great question. Thank you. So a Dapp is like decentralized application where, let me show you a video of, maybe I need to reach. Okay. So this is a decentralized, basic decentralized app. So in Web2, let's say if I am signing on the website, you have Google, Facebook, or whatever sign up option, or you can create your own email ID and password. In Web3 decentralized app, your MetaMask is your login. So once your website say login with MetaMask, basically I get access to your wallet address. And if I get access to your wallet address, I could like call my NFT contract and see if this wallet address, if my NFT owner or not, should I give them additional perks on my website for that, like things. So decentralized login. And second is you can now have decentralized assets integrated in your website, where I think, yeah, this is a good example where in this, if I know your wallet address, all of your NFTs publicly on chain, I can basically pull up all of your OpenSea NFT on my website, know which contract, what's the current price, and you can write various functions on it. And let's say you have users which are more into Web2, and they can't, you don't want to go and say call mint function from Etherscan. You want to have like a good looking website where you basically have, so right now I'm doing like a collection call function here. You can create the same mint call here where you can start minting from your own website. You can create like a transfer call here where you can say transfer from address A to B. And this becomes very useful because if you have your own collection, Why would you want to give OpenSea 2.5%? You can create your own website, create a mint function, start distributing it to your community. So it's like a decentralized way of database, user ID, front end calls.
Got it. Thank you.
Yeah, thanks for the question.
Would you
And
like
I think, yeah,
to,
go ahead.
yeah, would you like to tell us a little bit about like Dapp's pros and cons?
Yeah. Hmm. So Dev Pros is if you are like a website and a backend developer, it's challenging to create a login button, keep track of all of your like what's happening in like whenever I create like someone creates in Web2 a login button and you're creating your own password, then I need to have a database of keeping track of all of your password, and if that get leaks, it's very insecure. If you forget password, ways to update it. So all the need of that setup is gone within. I can show you. So the video which I was showing. Okay, this is another deb. So basically, it's very simple. So if we created this NFT deployment, right? Uh, let's say this is the one which I showed. All I need is this address of that NFT and ABI. Okay, so this is the transaction I did for SafeMint. ABI. Sorry for all the tabs. So let's say this is ArchiDAO NFT address. This is ArchiDAO ABI, like, and these are the functions you can call. So once I have this ABI, uh, first what I'll do on my decentralized app is uh, get me the wallet address of current user. So this is giving me this account variable. Once you log in, it's successful from your MetaMask. This account variable gives me your wallet address. Next thing is I'm instantiating my contract. Now you're making this bridge from HTTPS protocol to blockchain. So what I need to give is what's the contract address it's deployed and what are the functions you can call from this contract address. And once I get this, I can call all the functions. So in this smart contract, I had the public write function of count increase. And if people, and this, I think it's a button click. So, or if I click on this, it calls this function, which is on this contract, and you pay the gas fees, stuff like that. So you can even deploy your contract or transfer your contract. So within, like, this is very basic app, and you can see the amount of lines I was able to make a basic dApp very compact without even need of backend setup or other utility. The con is, what's the con? Yeah, you need some Web3 knowledge, and ultimately, uh, like for this video, I'm calling all the NFT collection. Wait, I think this is a good video how to set up a basic URI. The con is it's not easy to get all of my user data. For example, when Richa you mint, I think in Ethereum mint, every 13 seconds a block is being minted, and all of your data has been stored as byte in that block. So you could imagine like millions of block, and they're connected. And you minted your first NFT in 50th block, second in 10,000 block and stuff. So querying all the data is challenging. So that's why in this Dapp I used like a service called Moralis, which is like doing all, which is like caching all the data of yours and giving me like easy functions like get all the NFT of Richa or get all the tokens of Richa. So go scan the blog, give me only the address or event calls of Richa, and give me like a final output for this. So you might need to pay for those kind of services of getting of user data, or you can set up your own node and start collecting that data, but that's another skill requirement. But the reason I'm saying is if you have your own Dapp, you can make a dynamic NFT. Like imagine like if there's a Rhino compute or AR app, or you have a basic house configurator. Let people play with the variables and whatever new model it is, store it on IPFS, get the CID, uh, the content hash, embed it into your NFT URL metadata and give it them. Now you give your user a custom house which they can use in all the metaverse or they can use in their art gallery. So you're using your architectural knowledge there. Cool. I think I'll wrap up the session. It's already like a long time. So if you want to learn more and do next steps, definitely continue joining ArchiDAO study sessions where we experiment and do some hackathons so you can practice all the lean things and you can learn from each other. But I have compiled some resources on my GitHub. I'll share it on the chat too, where it goes Solidity Basics, Scaffold ETH is a good way to make quick dabs. And this is doing NFT on Remix, some tutorials on that, deployment, ABI from vanilla JavaScript front-end application. That is one thing I would recommend. And some other recommend. Open plain documentation is a good one. Then scaffold. There's also, I think like you might find all the good up-to-date videos on like uh, this guy has some Web3 Club has some amazing, very basic utility use cases. And if you want any BIM related, uh, I I hosted Theo Jonas on my channel. So you can check some tutorials there too. Like this is a workshop, so you could see how you can connect Grasshopper. I think they did the he's currently doing from like Blender to BIM to NFT, those kind of workflows. But yeah, just start it and start minting, start experimenting with it. One thing I forgot to tell is all the NFTs you deploy on testnet, if you want to check it, it's not on OpenSea main website. You can see it on OpenSea testnets. And do I need to connect? Okay, I'll connect again. Your collection over here. So these are all my experimental NFT. And this I can also, yeah, if I go on OpenSea, oh, like test. So this is Ringbit Etherscan, like testnet Etherscan. I can even send it to you. So
Like,
it
how
takes
do
some
we
time.
convert testnet into the mainnet?
Oh, good question. So basically, uh, if you, when you're deploying it here, okay, when you change wallet from testnet to Ethereum net, and then you click on deploy, now it's gonna deploy on mainnet. And if you want to deploy on Polygon, same code, you just change it to Polygon, and now you can deploy on Polygon. So
So my question will be
that's
like,
how it
how
is.
can I do it using OpenSea?
So OpenSea, like you just can create your NFT collection from here, and here you can select, okay, this I have collected on testnet. Here you can select Ethereum or Polygon. You mean you just want to create on OpenSea, right?
Yeah, my question is like, what if like the one you was showing us that on testnet you have something.
Hmm.
So and like I've created on testnet, but and now I'm thinking to make it on mainnet. Same thing.
Hmm.
Can I do
Yeah,
directly from OpenSea?
no. OpenSea just gives, OpenSea is just rendering all your things on Etherscan blockchain. So when I, so when I deployed like all my NFT on Etherscan, this testnet account is automatically rendering all my NFT here. I'm not doing nothing on OpenSea. So if you want to deploy f- on mainnet, as I showed, like Ethereum, just select mainnet here. If you want to deploy on testnet, just change it to testnet here. It's that easy. But you can't do conversion. You need to deploy another contract and do it.
Got
Okay. Can you give us tips for our safety? For example, there are many times we have to sign contract, but really not on this. For example, can you detect any red flag? Yeah, good question. So, uh, what I do is I have like one uh, developer account and one like my main account where I hold my assets. So for all the websites which seems fishy or something, like I generally do like fake account, like developer account logins to know whether it's genuine or not. And when you are signing, uh, there is a message you read, but also you can go to directly to the smart contract address and see what data are they capturing. Are they just using that signing message to get your wallet address, or they are indirectly getting money? Like they can't get money because there's another like message dot value or transaction functions you need to click if they want to get your money. But yeah, just going directly to the ether scan and verifying the contract if it's on Ethereum blockchain is safe. Actually,
Okay.
I wanted a feedback from you guys. So
Mhm.
like uh, what are the things you felt it was on the right pace? What are the things you wish I should have done detailed explanation, so for future or next session I can work accordingly?